Hello and welcome to today's OSForensics tutorial, where we will explore memory forensics analysis using the Memory Viewer module. OSForensics allows you to perform memory acquisition and forensic analysis on both live systems and static memory dumps. So let's get started. Once you have launched OSForensics, select the Memory Viewer module. Let's start with a look at live analysis. It is important to note that in order to process a live system, you would need to install OSForensics onto your USB device using the Install to USB feature located on the Start screen. Once installed, simply plug the OSF USB into a live system, launch OSF and navigate to the Memory Viewer module. Live analysis allows us to view real-time information about processes running on the system. When performing live analysis, the memory details of all processes currently running on the system are displayed in a Task Manager-like view. Unlike non-volatile hard disks, which can be analysed statically, memory contents, or RAM, can only be analysed while the system is live. Furthermore, it is possible that potentially implicating evidence exists only in the system's physical memory without any traces on the hard disk. This matter is complicated further if the data only exists in memory for a brief period of time. Within the live analysis view, by selecting a process, the user may view the process information, handles, modules, memory space, and memory layout. Let's start with process info. This view provides detailed insights into the application whose process was created. Next, we have handles. This view displays the list of handles used by the process. Moving on to modules, this view presents the list of modules loaded by the process. Next, memory space. This view illustrates the process memory allocation within its virtual address space. And lastly, we have memory layout. This view provides a graphical representation of the allocated memory sections within the process virtual address space. Within the Live Analysis tab, we can refresh the list of active processes in the system, select Window, which allows the user to select a process by clicking on its window, and dump physical memory, which will dump the entire physical memory into a binary file. For a guide on generating physical memory dump, see our video on the process. When browsing the active list of processes, by selecting and right-clicking the process list view, we have a range of options for further processing. We can export list of processes to disk, which will take a snapshot of the list of all running processes and save as a CSV on the disk. We can add the list of all processes to case, which will take a snapshot of all the list of running processes and add it to the case. We can dump physical memory to disk, which will dump the entire physical memory into a binary file on the disk. And we can also add physical memory dump to case, which will dump the entire physical memory and add it to the case. We can copy the entire row, which will copy the text of the selected row and add it to the clipboard. And we can copy value, which will copy the text of the selected cell and add it to the clipboard. We can also add checked items to the case or export them to disk. Within these two, we have the following options. Process details, which will take a snapshot of the selected processes and save it to the case or disk, or process memory snapshot, which will take a memory dump snapshot of the selected process details and save it to the case or disk. Lastly, we have combine process memory as a single file or generate list of checked processes. Now, let's take a look at the static analysis options. Static analysis is a powerful tool for investigators to dissect a memory snapshot dump taken recently. Through static analysis, investigators can uncover critical information, including a list of processes that were active, identification of suspicious processes, enumeration of installed drivers, detection of malware, file names and URLs of interest, BitLocker recovery keys, graphical user identifiers or GUIDs, email addresses, and more. To initiate the analysis of a memory dump file, simply navigate to its location and click on Open Memory Image in Volatility Workbench. This action will launch Volatility Workbench, a graphical user interface application designed for the Volatility tool. Volatility stands as a command line memory analysis and forensic tool crafted explicitly for extracting artifacts from memory dumps. It provides investigators with the means to delve deep into system memory for evidence. For further examination of raw data and extracted strings from the memory dump file, select the View and Extract Strings option. This action opens an internal viewer in HexView, equipped with tools tailored for the extraction and discovery of strings of interest such as passwords within the memory dump file. Filter Presets is also available, which can perform a real-time scan for file names, emails, URLs, and much more. Additionally, you can run the extracted strings against a word list with this feature. We hope this tutorial on memory forensics analysis using the Memory Viewer module in OSForensics has been informative. For more information on OSForensics or to download a free trial, visit osforensics.com.